forwarding table and given 5.5.5.5 space 32. Okay, so say these two commands we have to use it on all the routers to show it how the packet will be forwarding based upon the label. So show MPLS LDP binding 5.5.5 space 32 and show MPLS forwarding table 5.5.5.5 space 32. So same like R3 router, show MPLS LDP binding 5.5.5.5 space 32 and show MPLS forwarding table 5.5.5.5 space 32. Okay, next one, R4 router, show MPLS so LDP binding 5.5.5.5 space 32, enter. Show MPLS forwarding table 5.5.5.5 space 32, enter. So next one, R5 router, show MPLS LDP binding 5.5.5.5 so R5 router is a direct connected network, so 32 and show MPLS forwarding table 5.5.5.5 space 32. Okay, so now consider only one particular network and I will show it to you. So from R1 router, previously without MPLS, I will just give trace route. It will be the packet will be forwarding based upon the IP address. So now we can take it as an MPLS. So in R1 router, just I have to give show MPLS LDP binding. So 5.5.5 that MPLS, through that MPLS, so the local router assign the label as 102 and remote router assign the label as 202. So show MPLS forwarding table. So if I want to send the packet from 5.5.5 means my local label is 102 and outgoing label is 202. So automatically R1 forwarding the packet to R2. So outgoing interface is gig 2/0, that is through this interface. So the next hop is 10.10.2. So it automatically remove the 102 label and assign 202 label and forward that packet via gig 2/02 next hop is 10.10.2. Now the packet will be reaching the R2. So in R2 router, show MPLS LDP binding for 5.5.5. So the local label assign as 202 and remote label assign as 102 and 303. So this 102 indicates R1 and 303 indicates R3. So we should know how to reach 5.5.5. So R2 to R3 we will reach. But in R2 router we have two entry. One is either we can go R1 and another one is R3. So now in this case, how the R2 router send the packet correctly? So based upon the routing table, which one is the best part, it will select that entry. So now here we can see MPLS forwarding table 5.5.5/32. So local label is 202. Once I am receiving that packet, I remove the 202 label and assign 303 label and send it via gig 2/0 interface, that is outgoing interface, and next hop is 20.20.20.2. Now the packet will be comes to R3. So in R3, show MPLS LDP binding for the particular network. Now R3 router locally assign 5.5.5 as 303. So in R3, each and every router I set the MPLS label range. So that's why local binding R3 router means it will be 300 series, R2 router means 200 series. So 303 label. So remote binding. So there are two remote bindings are there. Two remote means R2 and R4. So R2 through the LDP it will advise that label for 5.5.5 network is 202 and R4 router advertising the same network with the label as 402. So again R3 router based upon that routing table, which one is the best path, it will be forwarding that label. So via 30.30.30.2. So now the local label is 303. So already R2 router send that packet 5.5.5 with 303 with R3 router. Now R3 router forwarding. So just removing that 303 label and inject 402 label. So outgoing interface is gig 2 bar 0 and next hop is 30.30.30.2 and send to the R4 router. Now in R4 router show MPLS LDP binding. So the local binding is 402 and remote binding is this one. Which one? R3 router and another remote binding is R5 router. So again we can see R3 router assign label as 303 and R5 router implicit null. So implicit null means the 5.5.5 network is R5 router direct connected network. So if it's direct connected network means the label should be an implicit null. So through the LDP it will advertise as an implicit null. So that's why it's showing here. So again if there is a 2 entry means the router will check its routing table which one is the best path it will select. So here we can see local label is 402 and outgoing label is pop-up label. So pop label means that 5.5.5 network is or the neighboring router is direct connected network. So that's why it's showing the pop label. So pop label means penultimate hop popping. So that means in R4 router while sending the packets to the R5 it will remove the label and it will send the packet based upon the IP version 4 and it will reach the destination. So because the neighboring router only that network is direct connected, so that's why here we have to remove that label. So that's why pop label, penultimate hop popping. So R5 router just remove the local label and send the outgoing interface via gig 2 bar 0 and next hop is 40.40.40.2. So remove the MPLS, it will sending through the normal IP version 4. So 5.5.5 in MPLS LDP binding we can see local binding. So the router locally assign label as implicit null because it's direct connected to R5 router. And remote binding is R4 router assign the label as 402. So in forwarding table show MPLS forwarding table 5.5.5 space 32. So local label is none and outgoing label also no label because if it's direct connected network. So now I just capture the Wireshark and parallelly I have to trace route and I'll show it to you. So likewise the packet will be forwarding based upon the labels. So here it won't check the layer 3 information. So based upon that label it will be forwarding that packets. Okay, next start capture. Okay, just I'm go to R1 router. I will just give trace route 5.5.5.5 source is loopback IP 1.1.1.1 enter. So here we can see. So for 10.10.2 I am using the 202 label to sending this packet and 202 from R2 to R3 I am using 303 label. From R3 to R4 I can use 402 label. Afterwards it remove the MPLS label, it will sending through normal IP version 4 packet. So previously we can check that packet while we are giving trace route the packet will be sending normally. Okay, so now I can stop this capture, stop capture, stop capture, stop capture and oh, I just close it and I stop capture. Okay, just go to first one R1 to R2. Just I will give ICMP enter. So just I'll capture once again. So next one, R2 router. Just I try to ping and I'll show it to you. Okay. So I'll just go to R1 router. So now I am going to ping 5.5.5.5 enter. So I am getting replay. So now I stop that capture. Okay. So now just go to that Wireshark capture. So first one is R1 to R2. So I will click ICMP enter. So just click any one packet. So here we can see in layer 2 this is a layer 3, so in between, so MPLS label is injected, so they will put 202 label, and step bottom of the label stack should be in 1 means this is the final label. In case if it's 0 means below one more label is there. So that one we can discuss about while we are configuring multi-protocol PGP. So on TTL is by default 255, it will be reducing, and experimental bit is 0, so this is for quality of service and traffic engineer, we can use that one. So that one also we can see later. So next one we can go to R2 to R3. Again I will type ICMP. So click any one packet and show it. So in MPLS label 303, so they will assign 303 label and it will send to the R3 router. So this is R2 to R3 capture. So same like I have to go to R3 to R4. I will type ICMP enter. So just click any one packet. So in here layer 2 and layer 3, so in between MPLS label is injected. Here we can see 402. So R3 to R4, before sending R3 to R4 they set the label as 402 and send to the R4 router. So the final one is R5, R4 to R5. So here I already told you it won't send that packet through label because R5 direct connected network, so it will send normal IP version 4. Here we can see there is no MPLS label. So using that, using MPLS, the label will be using the MPLS concept, the packet will be forwarding based upon the label. So I will show you two show commands, that is R1 R2 in show MPLS LDP binding. So show MPLS LDP binding looks what are the labels. So for particular network what are the labels it can learn. All the information should be there in show MPLS LDP binding command. And show MPLS forwarding table means the best path should be present here. So local label and outgoing label, because some of the terms, some of the networks have 2 to 3 label. I show it to you now. So for an example you can take R3. So here we can see there are 3 labels, local label and 2 neighboring label. So all the possible values should be present in show MPLS LDP binding command, and show MPLS forwarding, it will show the best path. So local label and outgoing label should be present. Okay friends, so this so In this video we have implemented that MPLS in the service provider network, that is in the rectangle box with all the 5 routers we configured MPLS. So in next session we are going to discuss about the LDP. So LDP, there is no configuration is required. Normally if you are giving MPLS to point-to-point network, automatically LDP is enabled. So I captured that Wireshark and I will show it how the LDP will be, neighbor relationship will be forming, and how the label will be advertising and receiving. Everything we will discuss on next session. So thank you for watching my videos. So if this video is useful to you, means just share to your friends also, and like and subscribe the channel for further updates. Okay friends, thank you.